All right, so we know that reaction rate is the speed of the reaction. So we've been talking about that forever. It's not the temperature, it's not a catalyst, it's speed. Symbol, we know that. I'm not going to go over that. We can talk about temperature. So when you heat something up, you have energy from your heat source going into the system. And so what's happening is that these particles are absorbing lots and lots of energy, so the particles have more energy to react. And so that's why when you heat something up, it reacts faster, because more particles have more energy to react. Does that part make sense?
Yes.
And so when we look at the graph, let me see if I can pull up another graph that is labeled. Let's take a look at this one. So we have our speed of our particles and our number of molecules. And so as we can think of this, we can think of this as increasing energy and our number of molecules. So as we have our system, not all the molecules are at a high speed. Most of them are at a normal speed. And so when we look at one like this, let me see one that has activation energy on it. This will work. So this area under the curve tells us how many molecules have what amount of energy. And so if they have high energy, if they're on the far right side of the scale, these particles have high energy. That means they have enough energy to react. And so these particles way over here, they don't have enough energy, because at this graph, we need at least this amount of energy to have a reaction. We good so far?
Yes.
And so when we look at the graph, if we have one with two temperatures, the height of the graph doesn't matter. What we care about is this area under the curve. And so at this EA, at the activation energy point, whichever one has more molecules that have enough energy to react, that's the one with the higher temperature. So now as we look at the catalyst one. So we saw the catalyst when we did the yeast and the peroxide. If you put peroxide on a cut, it's the same catalyst.
Oh, I have a question about this one. So how does the catalyst like change the exothermic and the endothermic reactions in terms of like products and reactants?
So the reactants and the products stays the same. What changes is the hump.
Is the height.
Yep.
Okay.
And so what this is from our reactant to our peak is our activation energy. Just like how on the other graph our activation energy is EA. Where did it go? Here.
Yeah.
Our activation on this graph is from reactants to peak.
Okay.
And so if the catalyst lowers the activation energy, it's lowering this peak.
Yeah.
And then, let's see. I know one that a lot of people missed is, what does the catalyst do to the molecules? And so a lot of people think that the catalyst gives the molecules more energy, but that's not what's going on. It's actually the second most important part is the orientation. So the way I think about it, if someone just kind of shoves you on the shoulder or whatever, you're not really going to react. But if they punch you in the face, you're going to react.
Yeah.
That would be proper orientation for a reaction. Does that kind of make sense?
Yes.
And so the catalyst takes the two molecules and puts them in the right arrangement for where they're going to react, instead of them just kind of randomly flying around in a soup hoping to crash into each other in the right way. And so we talked about the catalyst on that one. And And then the concentration I can talk about, I don't think it's as abstract as the other two. You increase concentration, you have more molecules. You have more molecules, you got more reaction. The way I think about it, if you have people in a room, if you have more people in a room, you're going to have more people running into each other.
Yeah.
And that's how I think about it as a reaction. Did you want me to go over some of the more mathy stuff?
Oh, there was a question on the more recent one. It was
The specific heat?
It was specific heat, yeah.
The summary quiz or the practice?
The summary because I skipped the practice.
Okay. Any specific question? You want me to kind of go through it?
There's like 2 specific questions.
Okay.
So I was looking at the go down a bit. That one. So I was jotting it down. I was like trying to order it with the equation Q equals mass.
C delta T.
Yeah. So I was trying to do it, but like I didn't get this like the starting. I didn't know which one was the starting or in the ending temperature.
Okay. So what happens if they only give you one temperature? That is the change. So you don't have to do that extra step.
Oh. I
So if
put
I
it
just
in and I got 0.04. So I think I did something wrong.
let's see if I can help out a little bit. You want me to type it up in a document or you want to get out the whiteboard?
I can get out a piece of paper.
Okay. Throw you over here. I'll open up something to write on this side.
I found the whiteboards.
You ready?
Yes.
Alrighty, so it says we got 15.1 grams of metal and it absorbs 48.75 joules of heat. Its temperature increases by 25 C, and we want to know the specific heat. So grams is the mass, so that's 15.1. If you're absorbing heat, or if it's just joules by itself, that's Q. So if we go back to
Wait, is this still chemistry?
yeah. It's got elements of physics in it, but it's still chemistry. But yeah, so Q is our energy transferred, our energy absorbed. Then we get to temperature, so our delta T is 25, and C we don't know. Up MC delta. We plug all the numbers in. And then solve for C.
So what I did was I multiplied 15.1 times 25, and I got that, and then I divided and I got 0. 0.04. I don't really.
Interesting. How did I get that before? I mean, the best answer choice would be A out of those options because it's the closest one.
Oh.
Maybe I wrote something down wrong. I took this question from an exam that we didn't take. I got it from here. Everything's typed up. Maybe just the answer choices were wrong. It happens all the time, to be honest.
So the answer would be A, most likely.
Yeah.
Because it goes here. Okay.
Yes.
Thank you.
Yes.
And then the other one was that one.
Okay.
But I guessed and I got it right.
Oh, you want to know why you got it right, though?
Yes.
So when you have these real lengthy ones, that should give you a red flag for a comparison, like how we take the two formulas and we put them together and set them equal to each other.
Yeah.
So the best way to get through that is to make a list of everything that you have. So let's see, we'll go back over here. We'll talk about those in a minute. So they tell us that we have aluminum. Aluminum is temperature 1, 275. We have water. We know that the mass is 200 grams. Its T1 is 25. And so then it tells us that the final temperature, so initial of the aluminum, mass of the water, temperature of the water. The final temperature of both is 50. So we'll plug those in. T2 is 50. And down here, T2 is 50. And we want to know what mass of aluminum we started with. So I'm going to tell you that the C of aluminum is 0.9. And for water, it is, we're going to round it off to 4.
Can you scroll up a little bit, please? Thank you.
So here's our water variables. Here's our aluminum. The mass, we don't know. So if we look at it, if we go from 275 to 50, are we gaining or losing energy?
Get out. I couldn't hear you.
In T1 to T2 right here in the aluminum, are we gaining or losing energy?
We are losing energy.
Yep, so we'll put lose here, which means that the water is gaining.
Yes.
So our formula is Q gain is equal to negative Q lost. And the idea is that energy is conserved because we can't create it, we can't destroy it, and that's why they're equal. And when you lose money from your bank account, it goes negative. And that's why we have Q lost as negative, to show that it's energy leaving the system. Good so far?
Yes.
And so if Q is equal to MC delta T, then we plug all of the stuff in for Q.
So just
So for the gain, we'll plug in all the water stuff. So we'll have 200 grams for 50 minus 25.
it's 25. And then for the aluminum, we don't know the mass for the aluminum.
And then we'll throw that negative in the front to cancel out the negative we'll get from the change in temperature, so that we don't end up with a negative mass, because that doesn't make any sense.
Okay.
And from there, it's just algebra. You solve for the mass. That's the easy part, right?
Yes.
Let me go over these graphy questions.
I got one of them wrong. I think it was the last one. No, I got yeah, it was the last one. I got confused between endothermic and exothermic again, but I understand.
The last one wrong. Come on, man.
Yeah, I understand it.
So the exothermic releases energy, because energy goes out, which means that the products don't have a lot of energy.
So exothermic would be B.
Those products have higher energy than the reactants.
I picked D and it said B.
Oh, well then it was a mistake on my part. I apologize.
Oh, okay. Thank you. I'm sorry.
No, don't worry about it. I can account for the points later when I do the grading, when I put it in Power School. Anything else on the specific heat?
No, not really.
Okay. How do we feel
Thank
about
you.
simulation? Do you want me to go through that a little bit?
Wait, the simulation?
This one?
I did the simulation. I found it easy. I found it understandable.
Good. And then I think we went over all the things.